All right, everybody ready? All right, so the first one is the angle bisector theorem. And it says, if a point is on the bisector of an angle, okay, what does it mean to bisect something? Cut it in half, okay? So if we have a point that lies on the bisector of an angle, then it is the same word as yesterday, equidistant from the sides of the angle, okay? Equidistant from the sides of the angle. If a point lies on the angle bisector, then it is equidistant from the sides of the angle. So if I have an angle here, we'll call it angle ABC. And then if I draw an angle bisector, that is going to be a ray that cuts my angle in half. Okay, so making these two little angles congruent. Then this point, or any point on this line, is going to be the same distance from the sides of the angles. So let me ask you this. Talking about distance, that's how long something is or how tall something is, correct? When you measure how tall you are, do you ever like stand sideways like this? No, you always make sure you stand how? Straight up and down, which means what kind of angle would we be forming with the ground? If I'm standing straight up. A right angle, okay? So when we talk about the distance to the sides of the triangle, we're talking about the distance from that point straight down, forming a right angle. Okay, so this one would be congruent to that one, if that makes sense, okay? But they have to be straight, forming a right angle, because that's the distance from a point to another point. My picture's a little bit different than what's up here, but so it says if BF in our picture, if ray BF, okay, there's my ray, is bisects angle DBE, so here's angle DBE, then what it says is that FD and FE would be equal to each other, okay? The reason it says they're perpendicular is, again, because the distance between a point and another one is the straight distance, the altitude, how directly straight. So that's why we have the right angles there. And then the converse of that is also true. It says if a point is on the interior of an angle and it is equidistant from the sides of the angle, then it is on the bisector of the angle. Okay. If a point on the interior of an angle is equidistant from the sides of the angles, then it is on the bisector of the angle. So in this case, what they would tell me is they would say FD is equal to FE. Okay, so those two segments are the same. That would lead me to know that these two little angles, even though the markings are already there in your picture, that those two angles are the same. So I'm either going to be told the two angles are the same, which means the distance to the sides is the same, or the opposite. I'm told the distance to the sides is the same, so therefore you would know the angles are the same. And it's just switching it around. It doesn't matter which one is told first, just as long as you know what that leads you to say next. So far, so good? All right, so let's look at our first example. It is asking me to find QT. It's asking me to find QT. The first thing I'm going to want to find is X. What do these little markings right here mean about these angles? They're congruent, which means this ray is the bisector, right? So then what could you tell me about the segment QT and the segment TS? Yep. Those two segments are going to be congruent. So in order to be able to find the length of QT, I'm going to set them equal to each other. I'm going to set that 4x plus 8 equal to the 9x plus 7. So take a second, solve that for x. It's not asking me for x, it's asking me for qt. So once I find x, I'm going to have to plug it in. But what we need to focus on first is finding what x is. Solve this equation for x. I personally am going to take my smaller x, my 4x, and subtract it over to my 9. Whoops. That's going to leave me with 8 equals 5x minus 7. Now I want to get that 7 all by itself. So, I'm sorry, not the 7. I want to get the 5x by itself.
And 8 plus 8 on both sides.
So I'm going to add the 7 on both sides, yep. That gives me 15 is equal to 5x. What is it that I need to do to get rid of the 5? Yep. And so what is x going to equal? 3. But is that what they were asking me for?
No.
Mm-mm. They want to know QT. So look at QT. It's right here. How much does it say it is?
4x plus 8.
So what I'm going to do is I'm going to plug in that 3 for x, and I'm going to figure out how long it is. What is 4 times 3? 12. And 12 plus 8 gives me a length of 20. Is everybody okay with that? Try the next example then. This time it is asking me for SP, so you need to solve for x first. Same exact type of problem. Once you have x, then you will need to plug it back in to find the length of SP. Again, looking at my picture, looking at my markings, it tells me that my 2 small angles down here are congruent, which means that these segments are also congruent. So I'm going to take and set them equal to each other. 3x plus 5 is equal to 6x minus 7. I'm going to subtract my 3x over to my 6x. I'm going to add my 7. And then I'm going to divide by 3. And so what is it that all of you got for x? What's 12 divided by 3? 4. Okay. So if x is 4, that's not what they were asking me for, though. They want SP. What does it say the length of SP is? What did I just highlight? Minus 7. So what I'm going to do is I'm going to plug that 4 in for x. And what is 24 minus 7?
17.
17. So the length of SP is going to be 17. Do I have any questions about that one? All right, go ahead and try the next one. It's looking for the measure of angle ZYW. The measure of angle ZYW. Do you have your angles marked congruent here in this picture? No. What is congruent though? My little segments right here, right? Aren't those congruent? Don't they both have a length of 5? So since those have the same distance from the sides of the angles, what is it that I know about this angle and this angle? They're going to be congruent. They are looking for ZYW, which is the small one. So what would that have to be? 38. I don't even really have to do any work. I just have to know that because both of those segments have the same length, that angle has been cut in half. And so therefore, if the top one is 38 degrees, so is the bottom one. Anybody have any questions so far? Okay. Now, we flip it over. We've got to talk about the point of concurrency for angle bisectors. We talked about the point of concurrency for perpendicular bisectors yesterday, and we learned that it was called the circumcenter and that it is the same distance from that point to each angle in your triangle. Okay, so this one is going to be a little different today. Oh, just kidding. I didn't realize there was another example at the top. Do that one first, and then we'll talk about the point of concurrency. It wants the measure of angle JKL. Sorry, I didn't realize there was one more example up there. What's marked congruent in this picture? Yeah, your two segments, JL and LM, which means that that angle has been what? Bisected. So if the bottom angle is 37 degrees, what would the top angle have to be? 37, yes. Okay, again, not much to do with that one. Just looking at your congruent markings, because these two pieces are the same, that means these two angles are the same. Everybody good? All right, now let's talk about it. So this is going to be very similar to what we did yesterday, except for it has a little bit more, a little bit different rule. Because a triangle has 3 angles, it also has 3 angle bisectors. Because a triangle has 3 angles, it also has 3 angle bisectors. Sorry, I had to make it smaller so I can read it. The angle bisectors of a triangle are concurrent, and their point of concurrency is called the incenter. I-N-C-E-N-T-R, the incenter. So for perpendicular bisectors, it was the circumcenter. For angle bisectors, it is called the incenter. And then we have the incenter theorem. What rule applies to it? The angle bisectors of a triangle intersect in a point called the incenter. And the rule for that, it is equidistance from the sides of the triangles. Not the angles, but the sides. So this is slightly different than what we talked about yesterday. And so what it says here in my example is if P is the incenter of triangle ABC, so here's P, then these three segments have to be congruent. PD has to be congruent to PE, has to be congruent to PF. It goes from that point of concurrency straight to the sides of the triangle, not to the angles this time, but to the sides. Okay, those are the three that are going to be equal this time with the incenter. Circumcenter, it was to each angle. Incenter is to the sides. Do I still have a bunch of right triangles in there? Yeah. Everybody ready? Okay. Now, we're going to be looking at this triangle. And what we're going to do is we're going to see what we can figure out before answering any questions. What's my incenter here? What point? In the second picture? P, okay? And we learned that the incenter is the same distance from the incenter to the sides of the triangle. So PM, PO, and PN would all be the same length. So what would they all be? 8. Okay, so I'm going to go ahead and label that as 8. And that is 8. So far, so good? Okay. Now, with the angle bisectors, here's another thing that we have to keep in mind. Okay, I'm going to look at this part right here. Now, do you notice that PN and PO are the same? Okay, that's what we labeled. That's what the rule says. So what did it say if a point was on the angle bisector? Oh, it didn't say that. I'm just kidding. What we need to know here is because these two PN and PO are congruent, that means that this big angle has been bisected. And another thing that we can say is, what is KO labeled as in this picture? 17. So that means that one is also 17. Okay. This is for incenters only. This doesn't work for any other point of concurrency. Only for incenters. Is there anything else that I'm given in this picture? I'm given the 13, right?
Yeah.
Does that say, do we know that that side PL is congruent to any other side? No. Okay, not with an incenter. So what we need to do now is let's take a look at what they're asking us for. What's the first segment they ask us for? NP, and what did we label NP as? 8. Then they're asking me for NK. Did we label that one?
Yes.
17. Okay. Then it wants PK. Do I know PK?
No.
No. All right, so let me blow that up and make it look. So we're looking for PK. So what I want to do is focus on this triangle right here. That's P. That's O. That's where my right angle is. That's K. This is labeled 17. This is labeled 8. This is what we're looking for. So what should we do like we did yesterday? We have to do the Pythagorean theorem. The first thing we want to do is figure out what our hypotenuse is. So what side is directly across from my right angle? X. So that x squared is going to be in the place of c. The other two, the order does not matter. I could put 18 squared. I could put 17 squared. Okay, it doesn't matter which one we put first. What does matter is that we figured out that x was my hypotenuse. So let's start working on it. Square 8, square 17, add those together. Mm-hmm. Mm-hmm. 353. Okay. And then, whoops. Of course it did. It's not been wanting to work all morning. So you're going to have x squared equals 353. Of course. Keep going up here. So we're going to have 353 equals x squared. Then what do I do to find x? I take the square root. So I need to go to my calculator and I need to do the square root of 353. And we're going to round it again to the nearest decimal, one decimal place.
18.8.
There you go. So we get 18.8 for PK. Let's see what else. They're asking us for. Is everybody okay with that one? Mm-hmm. All right. And then we're going to need to find LO.
17.
Okay, hold on. We need to talk about that. I need to draw the picture. Hold on just a second. Oh, go away. Let me see. Try this one more time, see if I can get it to connect before I draw. Nope. It's not going to work, is it? All right, give me 2 seconds. Let me draw this picture. Okay, so we know this is 17, we know this is 17, we know all of these are 8, and we just found out that that was 18.8, right? Oh, it also told me this one is 13. Yeah, okay, my picture's a little twisted, but same concept. So LO is what we're looking at. You said 17, right? Okay, but are these segments right here perpendicular bisectors? Are we dealing with perpendicular bisectors today? No. So these are not in the middle this time, okay? That's only if it's perpendicular bisectors or medians, which we haven't talked about yet. But when we're dealing with angle bisectors, this right here is not in the middle. So this side is not the same as that one. However, we can focus on this triangle right here. That's L, that's O, that's P, that's 8, that's 13, and we can find this one. Which one of these is my hypotenuse? 13, okay, the one directly across. So we're going to go 13 squared, and that's going to equal the other two squared and added together. So we are going to want to go through and square each one of these. Then we're going to want to subtract to get x squared by itself. And then we need to go to our calculator. We're going to round again to the nearest decimal. So we want the square root of 105. Which would be 10.2. So that's the answer to that last one on that example. Everybody okay? All right, I want you to start working on that last example there. I'm going to erase everything up here and draw it since I can't get my tablet to do what it's supposed to do. Hmm? Oh, thank you. All right, is everybody ready? So first of all, in the directions, it tells you that G is the end center. So that means that all of the sides to the all of those are going to be the same. Okay. What it also means is from the vertex to any point here, those are going to be the same on opposite sides. Okay, so what I'm going to fill out is, if this is 35, what is that going to be?
35.
35. And then I also have this segment. What else is going to be 6?
BF.
BF. Okay. And then it didn't tell me. Yeah, okay, so I don't know any of those segments. So let's start. I filled in everything that I could. I don't know what either of these sides are, so that's not going to help me. The first thing it asks me for is GD. Okay, so let's look. Here's GD right here, right? So we're going to focus on this triangle right here because I know 2 of the 3 sides. So I'm going to bring it down here. This side is 35. This side is 37. That side is what I'm looking for. So what I want you to do first is set up your Pythagorean theorem. Pick out your hypotenuse, that goes by itself. Then add the other 2 or square them and add them together. Round it to the nearest 10th place. Which one of these is my hypotenuse? 37, yeah. Look directly across from the right angle.